Hello, and welcome to Daniel Fritz Mathematics, the professor. And today we're going to talk about solving applied problems involving right triangles. Let's look at this particular problem. A surveyor can measure the width of a river by setting up a transit at point C on one side of the river and taking a sighting of a point A on the other side. After turning through an angle at 90 degrees at C, the surveyor walks a distance of 400 yards to point B. Using the transit at B, the angle theta is measured and found to be 40 degrees. What is the width of the river rounded to the nearest yards? Now, this is a surveying problem. He comes and he sets up at C first and takes a sighting on the other side of the river, then turns 90 degrees and walks 400 yards to point B and goes to the transit there and does another sighting there and has an angle measurement, angle reading of 40 degrees. Now, what we need to do is find the width of the river from here to here. So, what we have to do is set up an equation, or set up the trigonometric function tangent theta. So, here we have a triangle set up here, and on the adjacent side here is where he walked 400 yards. We have the angle 40 degrees, and we know that, and so now we have to find B, which is the width. So, setting this up, we find that tangent theta is equal to B divided by A, which is the opposite side over the adjacent side. So we must solve for B. And solving for B, we're going to take 400, we're going to multiply 400 to both sides, canceling out, and we get an expression of 400 tan 40 degrees is equal to B. So, I kind of switched them around here. It's the same thing. B is equal to 400 tan 40 degrees. So when you multiply that and take tangent 40, you're going to end up with 335.6 yards, which rounds to 336 yards. That is the width of the river from here to here. Let's do another problem. A meteorologist wants to take a light projector called a ceilometer. A ceilometer to find the height of the cloud covers. It was set up with a light detector 275 feet from its light projector. If the angle of the elevation from the light detector to the base of the cloud was 75 degrees, what was the height of the cloud cover? This is what meteorologists do. So basically, you have a ceilometer, which is just set up, and you have a light detector, and it shoots up a vertical beam or up to the clouds, and the light detector is able to see that, is able to detect the light there, seeing the base of the cloud. So in this case, what we have to do, we want to know what the cloud height is. So we set up the trigonometric function tangent theta, which is here in this case, the height tangent theta equal to the height divided by the base, which is the opposite side over the adjacent side. And the reason why we labeled H or spelled H out as the height is because that can be misconstrued or misunderstood as H being the hypotenuse. But in this case, it's not. It's the height in this case. Right? So tangent 75 degrees is equal to the height divided by 100 feet. 275 feet, excuse me. So tangent 75 degrees is equal to the height over 275 feet. So what we're going to do is we're going to solve for the height, which is h, multiplying 275 to both sides, and getting a height which equals to what? 275 times tan 75, tangent 75 degrees. So after you solve for that and you get that, you're going to get 275 times tan 75 degrees, and when you multiply that, you get a height of 1,026 feet. So the ceiling, which is the height to be of the base of a cloud-based cover, so you got the height to be the base of the clouds, of the base of the cloud cover, excuse me, was approximately 1,026 feet. Now, what we have, we solved the problem, the application problems for the height, finding the height, using the right triangle to solve the problem, and the trigonometric function in this case, which is tan theta for both of these problems. This concludes our video, and if you have any questions or anything, shoot me a nice email. And of course, we will continue to do more problems if you have questions and need help, and we'll solve more of these problems similar to these as well. Have a good evening.